Hi, my name is Dave. Today I'd like to show you this GOTO ST6. It's a school telescope. 60 millimeter school telescope from the 1980s. And it's very interesting, mostly because of the changes that GOTO made as they went through the years. This telescope is, a lot of it's plastic. And that's very uncharacteristic of the old GOTOs, from the 50s and 60s. This is mostly plastic. This is a replica. This is not original. This is a replica, but the original was also plastic. The dew shield and the focuser and the housing here. All of this stuff is all plastic. These are not original. These are actually a couple of Unitron screens that I put on here, but the originals I know are plastic because I had another GOTO SD6, different mount for it, but it's the same scope. So it's a very inexpensive telescope, and yet it's got the effectiveness of GOTO and superb optics, despite the fact that this is made with plate glass, an inexpensive kind of glass. But GOTO designed it to be an effective 60 millimeter telescope with cheap, inexpensive glass to make it. I'll show you some of the interesting features of this scope. I set these two scopes up next to each other so I could give you a comparison. This is the ST6 GOTO 60 millimeter telescope. This is a Takahashi TS65, same basic class telescope, f15 or so. Look at the difference in these telescopes, in the mounts and everything else. This telescope weighs about 6 pounds, just the OTA by itself. This thing is only 2.5 pounds. Really lightweight. This one is a horse. I think all of you who have handled Takahashi know how heavy Takahashi can be. And this thing weighs a ton. I'll just lift this up to show you. It's pretty heavy. It's a heavy telescope on that mount. This thing is feather. Oh my goodness, there's nothing to it. Good breeze will blow it over. So there's quite a difference between two 60 millimeter class telescopes of the same era. Admittedly, this one was clearly designed to be lightweight, and Takahashi is known for designing things to be really robust. Here are a couple of images from a GOTO catalog circa 1980s or so, and it shows this scope, which is an ST6. That's the scope right there, and it's called a model 1018. And it's right next to this, which is an ST5. It's basically the same scope, but it's only a 50 millimeter. Now that one is on the same mount, different aperture. Now here is identically the same scope. It's in the same catalog. It's called a model 1024, and it's exactly the same OTA. I can guarantee that. It's exactly the same telescope, but on a very different mount. This is an equatorial mount, big, robust, beefy mount. I will leave a link to the video about this telescope. I called it an ST6 Model 2, which may have been incorrect. Anyway, it's at least a 1024 is correct for sure. Here's a picture of the two of them side by side. Normally in my videos I would love to be able to place this telescope right next to this one and talk about them individually and compare them one for one. Can't do that because I sold this scope a couple years ago. Anyway, so it's long gone, but it is identical. It even has the same optics, and if I remember right, the performance is the same. Both of these telescopes are absolutely superb. I had this one out last night, and I was looking at the trapezium in Orion, and my goodness, I don't think I've ever seen a better view of the trapezium through a 60 millimeter telescope. This thing is astounding. It's got a special design with no spacers, contact edge contact doublet kind of a thing. Anyway, it's quite a wonderful scope. And if I remember right, and it's been a couple of years, but if I remember right, this scope was also superb, just absolutely superb optically. It always seems a little strange to me that they would put such superb optics into this kind of cheap, plasticky, I don't know. GOTO is always experimenting with things, so I guess that's the reason for it. The most unusual thing about this telescope, in my opinion, is this interesting Altaz mount. Now, this is a student telescope, so it's meant for students who are learning about the sky, hopefully. And it's got some features that are definitely meant to be instructive and don't serve too much of a practical purpose. For example, this altitude circle here has the whole circle marked. It's all indicated. That's completely unnecessary. You're only going to use 90 degrees of this. There's the indicator at 0. There's 90 degrees. That's the maximum you're going to use. The rest of it is there presumably strictly for instructional purposes. It doesn't serve any useful function other than that. In order to calibrate this thing for azimuth, you'd have to first of all find magnetic north. There's magnetic north. And then figure out your offset. You'd have to look on a map of the magnetic offsets from true north for your particular location. So when you do that, you find something, and let's just say, for example, I'm 10 degrees off, 10 degrees east or 10 degrees west. It would depend, of course. So let's offset this by 10 degrees here. Got this magnetic compass correct. So I'm offset by 10 degrees to figure out where things are in the sky. You would then just move this around. You have the correct azimuth setting. I'm not sure not sure how accurate it would be, but you'd get sort of close. It would probably be more accurate to set the scope to Polaris, which is about half a degree off, and then you would have your entire outfit calibrated. So once you get 0, then you can use these setting circles, if you will, to find something. You have to have an ephemeris. You give you the right ascension and declination, and then you use maybe a hand calculator or something. You're not going to use your iPhone because iPhones don't exist yet. It's the 1980s. So use a hand calculator of some sort to figure out where things are in the sky. Instructive, very instructive. Maybe not. I mean, this is a traditional set of setting circles on a small equatorial mount. They're not very good. I mean, these are too small to be of any use whatsoever. They're more or less for decoration. You can use a set of bigger setting circles on a bigger scope and precisely offset and so forth. It does work. I've done it, but it's not easy. These things here would be marginal at best, I think. Here's the eyepiece tray for this scope. Take off the lid. This is all plastic, by the way. All these parts are plastic. There's the star diagonal. There's a cap. Goes in somewhere. These bolts go through and go into the tripod arms. So there's your star diagonal. You have a 25mm Huygens. These are fairly decent eyepieces. Despite that being a Huygens, it's pretty good. It's not bad. Here's a 7, which is got 0 eye relief, but it would work okay. This one's 12.5. That's not too bad. And there's your never to be used sun filter. You don't ever want to put that on and try and use that. Let me show you a close-up of the slow motion on the azimuth. I don't know if you can see that or not. It's very slow. It's nice and, I mean, you can just grab the thing, friction, and then this will take over here. Very nice. It's actually a very nice effect. Okay, take a look at this. You can move it in altitude like so. Give it slow motions right here. You can probably see that. Very much, it's very nice. It's very much like a Unitron in feel. Let's compare this little mount with a Unitron. This is from a Unitron 114. By the way, notice how much higher the Unitron is. This thing is clearly designed for smaller people, like middle schoolers, maybe even elementary schoolers. It's got very short legs on it, relatively short legs, to make the telescope reach a height that's convenient for them. Anyway, if you think about this mount, I've really come to be, I'm really liking this mount quite a bit. The nice thing about this is that you can move the scope wherever you want and then still have slow motions. And this one, it's a wonderful mount. I think you probably have seen me in other videos wax on about how wonderful this mount is. It's a wonderful mount, very sturdy and robust. But you have to use these locks here. These locks, you have to tighten these down every time, and then you have really good slow motion. And sometimes, of course, you have to reset, so to speak. You have to rewind this because the spring gets too far out, so it's a little bit of a hassle in that respect. But for a lightweight telescope, this mount is really, really good. Similarly, this is only for a very lightweight scope. That scope, you probably couldn't get any sense of the heft of it from the video, but it's feather light. I think the tube is even plastic. But it weighs very, very little. But anyway, for a lightweight scope, this is adequate. This is quite adequate. And I've been toying with the idea of making a dovetail to fit in there. I don't think I would butcher the original dovetail and take it off. But put a dovetail in there and then make a sort of a universal mount, kind of like the Unitron is. This is what the dovetail looks like on this scope. You can see that it's angled on one side and straight on the other. It's a very nice design because you can slide the scope back and forth and balance it. And let's see, I can take it out. I'm kind of working backwards here. Anyway, that's a nice, that would be easy enough to make on a milling machine. I could easily make something with a profile like that to go into this mount. I might do that. I made a couple of adapters, just machined these on my milling machine. These adapters are just very simple dovetails that go right in here, slide right in, like so. Very nice. And you can, of course, attach all sorts of things. One of the things I have attached is this little Carton Mini 6 telescope. It's actually a little heavy for this mount because it weighs about 3.5 pounds. I wouldn't want to go any heavier than this. Anyway, we can slip that right on the dovetail. Now we have a cute little mount. I might need to adjust the friction up just a little bit. It's a little too heavy. Let me show you how you adjust the tension on this altitude. There's a set screw inside there. And that's just a screw, a couple of fiber kind of washers. I don't know what that material is, but it's just kind of some sort of fiber. This screws on like so. And you don't have that cinched down pretty tight to work. Then you lock it in with the set screw. That should be about right there. This thing won't hold a lot of weight. The OTA itself is only about 2.5 pounds. If you put maybe, you could probably go as far as 3.5 pounds. I hope you've enjoyed having a look at this GOTO ST6 student telescope from the 1980s. Thank you very much for watching.